And if we flip the upper magnet, it should be attracting and we can stretch the drop. Hi, my name is Mojtaba Falahati. I'm a graduate student in Washington State University. My major is mechanical engineering and material science. And we are doing some research in optical manufacturing and micro manufacturing lab in Washington State University. Our last research was related to development a new method for making some lenses. For making lenses, actually, there are two regular methods for making lenses, including casting or machining. And both of them requires complicated equipments and expensive molds. But in this technique, actually, we can make a very low-cost lens, and we can customize, and we can make whatever we want, which size we need. We published this research in Applied Physics Letter Journal, and our paper featured as a cover of that journal issued on May 2019. We began from finding some polymeric materials for making molds, but at the middle of this research, we found we can use some liquid mold, and it can be just a magnetic liquid, for example, a ferrofluid, water-based ferrofluid, which is immiscible with some hydrophobic materials, hydrophobic polymers, some like PDMS, and finally we developed this technique. We just use a drop of ferrofluid as a mold, and after making lens, we can reuse that drop. So this is reusable. This is our optical setup for measurement wavefront exiting from that lens. And after that, from that wavefront, we can measure the profile of the lens. We have a laser source right here. So we are going to lead this laser beam using these reflectors and this beam explitter right now. So the laser beam is going to go through these lenses and passing from two relay lenses. And finally, we have a sensor right there. This is a kind of camera and a micro lens array. Its name is Shag-Hartman sensor. Actually, this is a kind of experimental setup we made here. And we connect this sensor to the computer so we can get data from this sensor to the computer, and we developed a MATLAB code so we can get the data and convert it to some wavefront reconstruction. After that, using that wavefront, we can measure the profile of the lens and the focal length.